And I would request Professor Dhar to welcome Professor Sachin. Thank you. And I will request Dr. Faima to please welcome Professor Dhar for this session. Thank you. So now, without much delay, I would request Professor Dhar, head of the department, for his talk. Sir, please.
Thank you, Dr. Shweta. I am quite happy and pleased to. Like this or down?
You have to bend yourself.
Acha, like this. It is always a pleasure to have Professor Kunte with us. Professor Kunte has always been kind to be in various events which our department organizes, and he always adds a new energy to us through his visits. I'm quite happy that I've been a part of this event for the last 4 or 5 days. I've seen that all the participants are quite enthusiastic, and I'm hopeful that they have gained a lot. And this event must have really added to their knowledge. In my presentation, I'll be discussing the glacial fluctuations and landform development in the Chenab Basin, Northwest Himalayas, India. But I was trying to just find out whether I can connect it with the theme of this event. But since I'm into the glacial research for the last 25 years, I had definitely come across certain publications, some good publications, which report that climate change, which is the result of the glacial fluctuations in the Himalayan region, is not necessarily related to the aerosols, not related to the greenhouse gases, but there is an element of aerosol also. They have implicated aerosols also for climate change and glacial recession in the Himalayas. So, how these glaciers behave, and what are the landforms that are developed in the Himalayas, and why it is important to study glaciers, and what are the various disaster-related issues that are associated with the retreat of the glaciers. This small presentation will revolve around that. So, what I was talking earlier is that we have to basically why this black carbon and this and dust warms up the troposphere directly by absorbing solar radiations and reducing the albedo, so that the energies are not reflected back. We have seen it's a very good publication in American Chemical Society in the northeastern part of the Himalayas. It has been reported that these aerosols reach up to the glaciated regions of Himalayas also. So we have to imagine that they are traveling such a high altitude and reaching there. But apart from this, there was one more report which really enthused some kind of interest in me in trying to understand that as to why glacial fluctuations are more significant in northwest Himalayas rather than in the Karakoram region of the Himalayas, that is in the towards the western part of the Himalayas, not northwestern part of the Himalayas, is the report of the Vadian Institute of Himalayan Geology, in which Dr. P.S. Negi, he's a principal scientist in that institute, the DST Institute, which deals with the glacier, with the geological aspects of the Himalayas. He claims that about 0.10 microgram per cubic meter to 4.6 2 micrograms per cubic meter of black carbon has been reported in the Gangotri area. So it is again a surprising thing that if we have such a quantum of aerosols in the glaciers of Gangotri region, definitely they will have some kind of impact on the recession. So we should not attribute everything to the greenhouse gases. I think that aerosol content should not be overlooked. And apart from that, he also suggests that this black carbon is coming from Europe and other Asian countries apart from the plains of India. So the transport, you can see that how much the the distance these aerosols are traveling before they get settled on this white veneer of the Himalayas, that are the glaciers. Now, if we take into account the Himalayas, we should, I think most of you must be knowing what you must be having some idea about the Himalayas. Himalayas are basically convex arcs which spread for about 2,500 kilometer east-west direction, and their average width is about cross section is about 300 kilometers. Basically, if we see their extent, their northwestern extent is from the Indus Gorge, basically, and their their northeast extension is up to the what we say that Sangpo Gorge. They are the loftiest mountain ranges in the world, which are still rising. That is very important because of the tectonic because of peculiarities which these Himalayas have. They continue to rise, and this rise of the Himalayas, which is still continuing, has ramifications. It has some ramifications which are related to the geology and related to the seismology. That is why these Himalayas are seismically active. All the summits of the Himalayas are taller than all the summits which exist on the surface of the earth and are more than 7,000 meters. They exist in this part of the planet only. That is very important. And the mighty rivers of the Himalayas that rise from the highlands, they cater the needs of about 3 billion people. That is half the population of the world. So we can know what is the significance of Himalayas. And then, if we see the origin of the Himalayas, we know, most of us must be knowing Gondwana land. India was a part of Gondwana land, and then it was during the Triassic and the Jurassic times that they got split and started its northward drift like this. And it is by 45 million years back, it collided with the Eurasian plate, and that is how Himalayas were generated. That is how Himalayas took birth. Basically, the region which was between Eurasia and the Indian plate was a sedimentary regime where all the sediments were depositing, and these sediments, because of this compression, they got upwelled, and that is why these thrust systems got developed in Himalayas. And these thrust systems are basically responsible for new tectonic activity and other geomorphological readjustment that is taking place in the Himalayas. Now, if we see the physiography of the Himalayas, we have Great Himalayas, or we call them Himdaris, Lesser Himalayas, or Himachal Himalayas, or the Outer Himalayas, or the Shivaliks. The region, the terrain in which we are falling is basically a part of the outer fringe of the Outer Himalayas. That is the Shivalik system. And then Great Himalayas is a range which has an average height of about 6,000 meters. And we have the best possible ranges and some peaks. Mount Everest is again falls in this regime of Himalayas, Kanchenjunga, Dholagiri, Nanga Parbat, and some other important passes like Nathula Pass, Zojila Pass, and then Baralacha Pass. The lesser Himalayas are basically, they fall in the height range between 1,000 to 4,500 meters. We have Pir Panjal range, which is quite adjacent to us. South of Pir Panjal, we have this Jammu region, and north of Pir Panjal, we have the valley of the Kashmir. So this is how we have to understand the geographical the configuration of the various units of Himalayas in this region. Then we have Doladar Himalayas, which is a very important geomorphological feature in the Kangra Valley. Then Shimla, Dalhousie, Darjeeling, Chakrota, Mussoorie, Nainital, and the Valley of Kashmir, of course. The outer Himalayas or Shivaliks, this is the outermost range of the Himalayas, and its width is about 10 to 50 meters. It varies, the height varies between 900 to 1100 meters. We have these lesser Himalayas, we have Jammu Himalaya and the Himachal Himalayas. Now, what we have seen, one more thing I would like to add here is that if we see the cross section of the Himalayas from north to south, we have the Himalayas are more thick towards the northwest and they are thin towards the northeast.
If you come down, they are getting
Yes, they get thinner. And what I'm not aware whether you know what is the reason for that. The reason is that we don't have Shivaliks in northeastern sector. They are absent there. Shivalik, it is very surprising geologically that Shivaliks are absent in the northeast, but they are present in the northwest region, right up to the mid Himalayas. So that Shivalik, why they are absent, that is it's quite intriguing as a matter of fact, and that is why we should know that the first petroliferous deposits which we found in India was in northeast Himalayas only, because we had not to penetrate the Shivaliks there. We had directly go into the marine sequences where we can find the petroleum. But in the northwest also we have a lot of petroliferous deposits. But the thing is that we have to cross Shivaliks first.
Yeah.
Then we have to reach down to the marine sequences of Himalayas, and it's only there that we will get petroleum. But that's very costly affair. So that is why we don't go for petroleum exploration in this part of Himalayas. I think this is an important point which I wanted to bring home to you. Then, what are glaciers? Glacier is the largest reservoir of fresh water on the earth. See, if we take into account the fresh water, the resources of the earth, glaciers account for the largest fresh water, because we have the polar regions and then we have the alpine Himalayan region. So, if we leave polar region aside, these glaciers of the Himalayas comprise the largest freshwater reservoir on the surface of the earth, and second only to the oceans as the largest reservoir total water. So these are very important. We can see the glaciated areas of the world, of our planet. We have north and south. We have North Pole. We have South Pole regions, Antarctica, Arctic region, and then these glaciated, these alpine glaciers which occur in Himalayas as well as in the alpine region, and especially in the North American and the Southern American regions also. The movement of glaciers is very important. We cannot discern the movement of the glaciers, but glaciers are definitely moving. Excuse me.
Yes.
Glaciers keep on moving, and this movement of glaciers is very important, significant geologically. Why it is significant, we'll come to know about that thing also. Now, so long as Himalayas are concerned to be, Himalaya is the largest reservoir of glacier stored water outside polar region. And the glaciated region of the Himalayas is more than 33,000 square kilometers. And the runoff of the glaciers is very important, so long as our India is concerned to be, because most of the rivers that flow out into the Indus and the Brahmaputra basin, that is all glaciated water. So the perenniality of these river systems, these two important basins, that is Ganga basin, Brahmaputra basin, and the Indus basin, is completely dependent upon what? Dependent upon glaciers. We can see that here, this is the picture of Mount Everest. We can see how satellite image of Mount Everest, and then we have a glacier in the Lahore Spiti. How does this pointer work? Correct. So this peak is the Mount Everest, and this is a field photograph of a glacier which is situated in the Lahore area of Himachal Pradesh. This glacier is known as Samudra Tapu Glacier. It is the second largest glacier after Badashigiri Glacier, and it is about 17-18 kilometers in length. Then See, I have been working on the Chenab Basin for the last 25 years. Earlier, I was working on the Chenab Basin of Himachal Pradesh area. And then once I shifted to this place, then I took the Chenab Basin of the Jammu and Kashmir area, because this Chenab Basin straddles the boundaries of two states, that is Lahore Spiti and Chamba. And Lahore Spiti and Kashtwad region of Jammu and Kashmir. We can see from here, these are different districts which we see in Himachal Pradesh. And if we see the state of Himachal Pradesh, the northwest and northeastern part of this state is completely glaciated. These are the region where we have glaciers. And this state is significant because most of the rivers which feed the Indus Basin, they emanate from this state only. Here we can see this Lahore and Spiti area is the catchment of Chenab Basin, which is known as Chandrabhaga in Himachal Pradesh. And then we have this region, Kinnaur and Shimla district. This is the catchment for Satluj River. Similarly, this Chamba region is the catchment for Ravi. And then this Kullu region is the catchment for Byas River. So 4 important rivers of northern India, they emanate from Himachal Pradesh. This Satluj, most of the catchment of Satluj, because here we have China. So around half of the catchment of Satluj is in Indian part and the half is in the Chinese part. Then I have tried to mark these important basins here also. This is the Chenab Basin, which falls between the Pir Panjab Range and Great Himalayan Range. This is the Satluj red. Then we have Byas is blue. Then Ravi Basin is again pink. From this, we can actually see that the glaciated region of Himachal Pradesh is tremendous, and that is why it has given rise to these 4 important river systems, which ultimately culminate into Indus Basin and have contributed a lot in the development and civilizational changes of the northern part of India. Then, if we see the overview of the Chenab Basin, we can very well see that this Chenab Basin, we have Himachal Pradesh also here, somewhere here. This river is emanating like this. Then it enters into Kashtwad region from here. From Kashtwad, it takes a bend right down. It comes down to the Akhnur region. Then from Akhnur region, it enters into Pakistan before it enters the Indus Basin. So again, the trajectory of Chenab Basin can be seen again here. This is in Himachal Pradesh, it is termed as Chandrabhaga because there are 2 important river systems which join at Tandi region of this Lahore Spiti, Chandra and Bhaga, and they form Chandrabhaga. And once it enters J&K, it is termed as Chenab here in J&K. So this is the great now this basin, basically, if we see the this disposition of this basin, it is basically between this river is basically situated between the Great Himalayan Range and this is the Pir Panjab Range. So we have glaciers here. These form the catchment of this. You can see so many glaciers are here. But the maximum, we have 2 important catchments for this river system. One is in Himachal Pradesh here, and one is in Kashtwad region, that is in Jammu and Kashmir. These are the main feeders of this river. This river comes like this. It takes a sharp bend here. Why it takes a sharp bend here? There's again a geological reason for that. I would not like to go in that right now because it will be difficult for you to understand that. Otherwise, it should have gone straight like here. But it's taking a bend here, almost 90-degree bend. 90-degree bend because we have a thrust system here. Kashtwad thrust is there. This river has basically the rocks here, they have got uplifted and they have prevented this river to proceed. If it had proceeded, it would have gone into the valley of Kashmir. So it is taking bend here, 90-degree bend, coming down like this Akhnur and entering into Pakistan. Then again, some important glaciers of the river Chenab. Then let me not go to that. So I would just like to discuss certain features that are developed because of the recession that is associated with these glaciers, and of course, what is the reservoir health of Chenab Basin that I'm keen to discuss with you. So, if we take into account the region of Chenab Basin in Himachal Pradesh, we can just see here that this Basin covers about 7,510 square kilometers. This Chandrabhaga Basin, which is as it is termed in Himachal Pradesh, and most of the glaciers which we have studied, because reaching to a glacier is not an easy job. It is a very difficult job, because if we have to reach to a glacier, if we have to reach a glacier, that means we have to at least go up to the height of more than 18,000 feet above sea level. And the terrain is rugged. You don't have any transport system. You have to walk, and then you have to camp there. Camping is very important. Logistics are very difficult. But our team, I have been associated with the Space Application Center, and of course IIC Bangalore also. So that is how we had a very good team, energetic team, being which was led by Professor Anil Kulkarni. So that is how we could manage to go to these regions, and we could study them from ground zero only. Because remote sensing techniques, whatever I'm showing you right now, these are basically, this is data equivalent to remote sensing techniques. Because remote sensing technique is a technique which helps us acquire data from those regions which are not which we cannot the regions or localities where we cannot physically reach. So we can just see this again a remote sensing data, list 3 data of the Chandra basin, or not the Bhaga basin. Some important glaciers which we have studied in this basin. We can just, this is the largest this glacier of this basin, that is Samudra Tapu glacier. A lake is being formed here, and this is Chandratal Lake. You must have heard about Chandratal Lake. It's a very important lake of Lahore area. And then these are the glaciers which were these worm-like things. They are all glaciers. So reaching these glaciers is not an easy thing. You can reach up to this region, but going to a glacier, staying there, it is a very difficult job. But people do it. We have also done it. So if we see, we have in our study, what we did is that we tried to study these glaciers in such a way, in order to know their recession, their retreat, we try to divide them according to their orientation, number one, and according to their altitude. So if we see this, so there were 3 zones which we demarcated. This is the one which is on the Pir Panjal range. This is the Great Himalayan range here. This is the Spiti region. Completely, these are all limestones on which these glaciers have been formed. And this is the central zone, is the region between Great Himalayas and Pir Panjal range. Just try to see if some altitudinal impact is visible there or not. So 3 benchmark glaciers were studied. The attributes of these benchmark glaciers are visible here. Samudra Tapu, we can see that its length is about 16 kilometers. Catchment is 87 square kilometers. Ice cover 80 kilometers. Similarly, Kipangat Glacier 5.5 kilometers length, and then Batal Glacier 6.3 kilometers. And other attributes are also visible. So long as Chandratal, this Samudra Tapu Glacier is concerned to be, you can see the real-time photograph of this glacier, and this is the Landsat image of this glacier. Attributes I have told you. What important change we could find in this glacier is that we have tried to analyze the development of a lake which is being formed at its snout. This development of lake is basically associated with the change in the climate. These dimensions of the lake are increasing, and we have seen from 1976 up to 2009. This is data which we had studied. We have some more data which were acquired now, but we have not incorporated it here. But we can see very well that from 76 to 2009, the dimensions of these lakes are increasing. That is basically because of the global warming, impact of climate change, that this lake is forming there. And these lakes, which are situated at such formidable heights, we cannot monitor them easily. And all of a sudden, if they break out, if they outbreak, there is definitely going to be floods in the downstream areas. That is what we are seeing of late. We are seeing in this Gangotri region or in the basin of Ganga, there is a lot of floods are taking place because of the outburst of these lakes only, which we term as glacial lake outburst floods, GLOFs. So then we can see the recession of this glacier over a period of time. Then the development of this glacier, we have tried to mark certain regions to see as to how this change in the snout region of the glacier and the development of lake is taking place, how this enlargement of lake is taking place. And then these are some field photographs that are which we have taken there, and we can see certain geomorphological features, very important. If at least these are some morainal deposits here, at least we can be sure that the lake existed up to this place in the recent past, because the moraine can be deposited only if the glacier was existing there. So at least we can say that from the place where the last moraine is there in the downstream region up to the snout region, the glaciation must have taken place. And because the moraine is still intact, these moraines are washed away basically because of the water that emanates from the snout. If it is intact, that means it is not a old feature, it is a new feature. So then this is the second glacier which we have seen. It is very important so long as it's this development of lake is considered to be. This lake is very ominous, and it has all the attributes of Loaf. It's a Kipangad glacier, and it is also enlarging at a very fast rate. We can see here, and then the enlargement is visible from the fact that if we have this 2007 photograph, you can see the stream coming into this here, and here you can just see the stream is somewhere here. That means this much of ice has been lost to the enlargement of the lake. Then this is the field photograph of this lake. This is the wall which is holding this water. If this wall breaks down, we have lots of villages in the downstream areas. I think Vijay must be knowing it. We have Sisu there, which is in the downstream area. So it can pose a lot of threat to that village if there is outburst of this lake. Then we have third glacier that we studied was the Batal Glacier. So we can see the recession of this glacier, this snout region of this glacier. What is important? The most important thing that we studied in this is that this lake must have advanced in some during the recent past. Because of its advancement, it has deposited these moraines across the river. We have identified moraines across the Chandra River. That means this glacier must have advanced in the recent past, and because of its advancement, it must have impounded the water of this river, which is visible here. And for a quite substantial period of time, this whole region was inundated underwater. That is why this. Then we tried to just see whether there are some, because probably we could feel that it is not an old event, as a matter of fact. Then we tried to inquire from local people who live in the downstream region, because this region is not inhabited. It is uninhabited region. They told that this region has the name of the region is known as Samundra Tapu, because it was a samundar just like Samundar, and there were small islands in that. And then once the lake waters got drained out, this riverbed and the valley got exposed. So this is how. And then we have some lakes, development of some lakes in the Kashtwad region, in the region of Jammu Himalayas. We have seen the development of such kind of lakes again taking place, which otherwise are not reported. We can just see in this slide, we can see the Brahma Glacier is one of the most important glaciers of this Chenab basin in the Kashtwad region. We can just see how it is behaving. There are a lot of development of lakes taking place here in this region. How this ice is being getting melted because of the rise in temperatures, and how these small subterranean channels are being formed. And then again, some glaciers in the high altitude Kashtwad area, we can just see that glacier advance must have taken place here up to this region, and then it is now again retreating. It is quite visible here. So again, this snout region, that is the tongue region of this glacier, how geomorphological changes are taking place here. And again, the same glaciers here. They are in the Gyad Nala of Chenab River. And these are some geomorphological features which we can see here. These are the morainal deposits, and these are the outwashes. from the streams which are visible here. The U-shaped valleys that are carved because of glaciers only, typical. And then we can see again the development of some lakes in the other regions of Kashtwad area. And I should now skip some slides because I'm taking more time. We can just see how the development of lakes is basically related to the retreat and the loss of the area of the glacier. This is the area of the glacier. This is development of the lake, and this is the retreat that is taking place. You can see there is a very well established correlation that takes place between retreat, then area loss, and the enlargement of the lakes. So again, the same thing we can see here in another lake. We have tried to. There are certain methods by which we can estimate the volume of the water that is impounded and the peak discharge if there is an outburst of the lake. We can see that most of the lakes, the peak discharge is quite substantial, and God forbid if there is a discharge that takes place, or if there is a accidental discharge of these lakes that takes place, there will be a lot of places that will be damaged, especially both in the Lahore Spiti region as well as in the Kashtwad region. I just tried to highlight it here. We have lots of villages here, and the images which I have shown you are in the catchment area of this small stream. So God forbid if the water is drained out here in these streams, there will be a lot of damage that can take place. This is the Maru Sudar River, a very important tributary of Chenab River. And then some peculiarities of Chenab Basin of Jammu region. This the study which I carried out in this region, there were a lot of misrumors and there were some beliefs which I thought that I should clear it with my participants here. One of the important region is that Jammu region has more glaciers than Kashmir region. We should know it very well. But we always think that the the Himalayas have more glaciers. We definitely Kashmir region is older than the Jammu region, but we have more of snow cover there rather than glaciers. Snow cover is more there because of altitude, and glaciers we have on the southern flank of Pir Punjab range only. Once we talk of Jammu region, it is not Jammu city. We should try to, because there are so many people who don't belong to this state. Jammu region comprises the hilly, almost 80 to 85% of the landscape of Jammu region is hilly. We have Rajouri, we have Punj, we have Kashtwad, we have Bhadrawa, we have Udhampur, isn't it? Only there are 2 districts or 3 districts which are adjacent to the Punjab alluvium or the alluvial plains of India. That is Jammu district, part of Jammu district, then Samba district, and the Kotha district. So the southern slope, that is slope towards Jammu region, has more glaciers than the northern slope, which faces the Kashmir Valley. That we should know very well. The river systems in Kashmir region are driven more by permanent snow rather than glaciers. That is again an important point which all of you should remember. The perenniality and the sustainable ecosystem in Chenab Valley of Jammu region is directly related to the longevity of the glaciers. So longevity of the glaciers, because this is a dry area, this is a more hotter area. So the perenniality of glaciers is more important here rather than in Kashmir Valley. That is another important point. Then disaster-related glacial outbursts will impact Jammu region more rather than Kashmir, because we don't have more glaciers there. Development of glacial lakes is less in Kashmir region, Kashmir Himalayas, rather than the Jammu Himalayas. Then the vagaries of climate has more pronounced impact on the glacial retreat in the southern slope of Pir Panjal, that is slope which descends into the Jammu city, occupying Chenab catchment in the Jammu province, and the development of globe characteristics lakes is more important here. So with this, I have some couple of slides which can show that how dangerous and how catastrophic these development of lakes are, and if once they release the water that is impounded because of one or the reason by these lakes, and if their water is released and what it can do. We have an incident of Parachu Lake breach in the Satluj basin of Shimla district in 2005. It almost devastated the downstream area of Shimla district. And then we can just see the Uttarakhand disaster of 16-17 June 2013. We can just two glaciers, development of lake here, and this is the Chorabari glacier, and this is the companion glacier. The release of water, we can see the Badrinath before and Badrinath after. And again, the satellite image of this, the waters that were released from the development of lakes in the upper catchment of the Badrinath region. We can see this, how this road that leads to Badrinath existed before this catastrophe that took place, and then what happened after the release of the water. And with this, I end my this presentation. Thank you very much.
Thank you so much, sir, for a wonderful presentation. I must thank sir for telling us in detail about the Himalayas, because whenever we are designing any sampling in Himalayas, we need to know the region better. So thank you so much, sir. Once again, I would request Dr. Isha ma'am to please honor sir with a memento. I would also request, I'll also request co-conveners of this winter school. Lieutenant Dr. Pankaj Mehta is with us now, and Dr. Dinesh.
I think Dr. Pankaj should come
Sachin, come.
fully armed.
Yeah. Actually, I get only directly from the camp, and from the camp I am traveling
Yes,
straight away.
I appreciate your enthusiasm.
Yes.
Nice.
पंकज सर का ये भी सवाल है.
Thank you.
Thank you. So now, so before I proceed, I must thank few people here sitting here, because for this winter school, one of the major challenge was accommodation, right? So Dr. Pankaj was convener of this accommodation committee, and before you came here, we were looking for good accommodations. We went to Cost guest house. He was with me, and we went to different hotels also to see a good one. I also appreciate Dr. Shweta Kohli ma'am, who is also hostel warden of girls hostel. I think if you are here, you should chair this session. Dr. Shweta, please come on the dais. So madam very kindly agreed and kept our girls scholars in the hostel. So a big round of applause for the accommodation committee. Pankaj sir, please come on the dais. So we had been missing you. Shweta, you come here because you're Shweta only, no? I think anything. So without much delay, now I'm going to request Professor Sachin S. Gunte, eminent speaker of the day, for his talk. Sir is professor and former head of Max Planck Partner Group on Bioresource Research at IIT Madras. He is involved in teaching diverse courses in the field of environmental engineering and earth system science and climate change at undergraduate and graduate levels. He also leads a research group of approximately 20 PhD students, master's students, project staff, and postdoctoral fellow, investigating the problems which are at the forefront of the earth system science, mainly focusing on aerosol biosphere climate interaction. Sir is very kind. He has not written in his brief that his students are already faculty like places like IIT Jodhpur and all. So without much delay, I would request Professor Kunte to come for his talk on insights on water-soluble allic species and sea formation. Sir, please.
I don't think so. I would really need the mic here. I'm probably loud enough. So why don't some of you just come in the front, right? So I'll try to keep you entertained. Sir, I must say that I did a mistake, and then when I did a mistake, the madam took a very proper revenge, because I forgot to send the references for my abstract, and I was very last one to do that, right? So I didn't know that I would be put in the last to this workshop, so that all you have exhausted and drained, and then I'm put in there, and then आप बोलोगे कि अरे यार अभी यार सब और मतलब और bore करेंगे इसमें, right? I'm not going to do that essentially. So first of all, thank you for all the organizers, particularly Dr. Shweta, and then this department is now becoming second home for me, right? The reason for that, after IIT Madras, if I'm doing some science, that is here. So every time when I say that I'm going for a workshop or for a talk or some sort of a research, they said, "अच्छा जम्मू जा रहे हो क्या?" Because और कहीं पे तो science होती नहीं है basically. Anyway, so without much delay with that, let me come back to the topic. And by the way, sir, first of all, thank you very much arranging this in person, right? Because I thought that I was talking to my daughter, and then we were discussing that, like, what is the difference between this online and offline workshops nowadays? And she said Wi-Fi. Right? I said, okay, that's fair enough. So you don't need a Wi-Fi when you are in person because you are directly listening to the speakers. Just for all of you, a humble request that when I'm speaking something here, get your expressions right. I mean, I'll take another 30 seconds to tell a story. I was raised by my grandparents, and then when I was raised by my grandparents, my grandmother, she was suffering from diabetes and BP both at the same time. So once she fainted in the morning at around 10 o'clock, she fainted, and my grandfather told me that just go run and bring Dr. Panat. So this was probably in late 80s. I was talking about 1989 or something. I was 10, 11 years old. So I ran, and then there was this doctor who was very strong, and this old school of thought, he would have this big thing. And then literally, as you might have seen in the old movies, I was carrying his bag, and then he came there. And then those people generally believed more on the pulses like this, right? So, and then Dr. Panat came, and then for a long time he examined, and then he was holding this pulse. And he said, literally for 3 to 5 minutes, he was just doing nothing. I said, what happened? Then he says that nothing to worry. Then I said, get your expression right? There is nothing to worry. Then get your expressions right? So when you don't understand here anything, please get your expression right? So if you are understanding something, just nod your head. That will encourage me, right? So he was a doctor. He was doing some sort of his work. So that's fine. I couldn't tell him that. At least you should have not said that, right? So my humble request to all of you is that please get your expression right. Okay. So let's get started with this. I was given two topics to talk on this particular winter school. One was told that formation of the secondary inorganic aerosol, which I tweaked a little bit because I thought that some of chemists here, some of them us are physicists here, and it doesn't really depend on which background we are from. Like I'm a physicist and working in the civil engineering department in the top institution in the country. So it really doesn't matter how interdisciplinary it is. Before I start, this is the team at Aerosol Group at Center for Atmospheric and Climate Sciences. It is not possible without the very good, hardworking student and, of course, the collaborator, right? It also starts with Dr. Shweta in the northernmost region, and then through Ankit, it goes to IIT Kanpur and then Darjeeling and everywhere, right? I'm a firm believer that it's always good to collaborate. The reason is that you can give your ideas to others and just relax, because out of 199 will help you and only one will steal. So still that's a good deal. So I'm a very firm believer in collaboration, and then this is what I always try to do. All right, get started with this. This is the most rough outline which I'm going to follow as far as my today's talk is concerned. So at any point of time, if you have any question, just raise your hand and say that I did not understand this. Because asking question is different from questioning somebody, right? So don't hesitate to do with that. So we'll try to talk about what are the water-soluble ionic species are, that's an introduction to it, sources of the water-soluble inorganic species in the atmosphere, where do they come from? Then try to talk about the transport and transformation of these species, because then this is how they shape up our atmosphere. Then impact of these water-soluble inorganic species on the atmosphere itself, and then how this feedback basically works. Secondary inorganic aerosol, that was the topic which was actually given to me. So my apologies that I took this liberty to slightly tweak it as per what I needed. And then there are again these certain sub-aspect related to that. We'll try to talk about the analytical techniques for atmospheric water-soluble inorganic species and secondary inorganic measurement. You have had a nice round for the labs, as I understand, and you probably had some hands-on on some of the instruments anyway. The climate implication, the control strategies for the secondary organic aerosol, and then I'll try to conclude about this. What are these water-soluble inorganic species? Like, very basic chemistry, probably something chemistry which I learned in 8th standard or maybe 12th standard, that is being taught in the 6th standard now. It is just the iron present in the form of soluble salt, right? Which can dissolve in atmospheric water droplets, and then such as a cloud or rain droplets. And then simply like, what you are doing is that you have a beaker, you put some salt in that and you are dissolving it. Just try to imagine that like you have some sort of a water vapor, and then these, as a Lagrangian system, your droplet, your salt or the solid particles is kind of traveling through it and then obviously getting dissolved in that. Now, where do these species basically come from? They originate from both natural as well as anthropogenic sources. If you go into the past, volcanic eruption, obviously one of the strong sources, through a variety of chemical reactions that occur in the atmosphere, right? One of these could be essentially gas to particle conversion, but I would not go into the much detail of that. Could be transported over the long distances and deposited on the surface, which are kind of through the precipitation, because the aerosols, they know no boundaries, like having a lifetime of roughly around 7 to 30 days. They can really transport all the earth and then kind of come back to the same thing. And then the last important point here, that they can have a significant impact as far as the atmospheric chemistry and air quality and climate is concerned. How these three are interlinked, that's probably for some other talk, but they can definitely influence the chemistry, air quality, and health. Major these things like these ions and cations, that's again the basic chemistry, like you have ammonium sulfate, ammonium nitrate, ammonium chloride. What happens in the atmosphere, however, is that depending upon the neutralization capacity, their concentration may vary. Like, so if you look into the ammonium, it would try to neutralize the sulfate first, and then maybe nitrate, and then maybe chloride. And if you still have excess ammonium, and then this concentration is high, there is something which you would really need to worry. So it's really a basic chemistry which you have studied in the school days. You just need to apply that in the atmosphere in a slightly different way. Let's try to bifurcate these sources now slightly in detail, so that it will, as we progress, it will help you to basically understand that why do we need to categorize and what kind of a different impacts they have in the atmosphere. The natural sources, of course, sea salt, volcanic emissions, dust and soil particles, and then the biogenic emissions. Anthropogenic sources, industrial emission, transportation, agriculture, and biomass burning. Now, the difference, what happens is here, I'll give you a very quick example. If I find a high chloride in Delhi, obviously you don't expect it is coming from the sea salt, because that acid displacement is one of the source, and then you don't really get such a strong long range transport of a sodium chloride particle as far as Delhi is concerned. So I would not, I don't know if you can see this still. If you look into the secondary conversion of you have like sulfate, nitrate, and ammonium, and then the PM 2.5, that is a particulate matter. You might have seen that over the last so many days, that this particular, I think it is working here. Yeah, so maybe I would just kind of stand on this side, because I'm anyway it's loud enough. So it's better that I stand. Can you still hear? Yes. Okay, then that's good. So I would, without getting into the details of this, the one of the important things which we say here is that why there is a difference between the cold months and the hot months. If you look into the secondary nitrate aerosol here, and then the other ions, how you can basically see that not only the difference in the size, but in the meteorology also plays an important role. So what happens is that the relative contribution of these atmospheric concentration to the secondary inorganic aerosol in terms of the ionic species is really depend on the changing season, meteorology, and as well as the emission pattern. So they all are interlinked together. Like if you have same emission patterns, but if you have a different meteorology, it's going to play a different role. And we will see that basically why and how it happens. Transport and transformation of water-soluble ionic species in the atmosphere. Now we basically see that there is a physical and chemical processes, like as they go, the advection happens, of course, and then they do undergo the aging that basically changes their properties. Of course, diffusion, deposition, gas to particle conversion, that's what we basically call the formation of the secondary organic aerosol or the inorganic aerosol. That's all basically comes under the chemistry. The influence of the meteorological conditions such as temperature, humidity, wind speed, and precipitations are important. Amongst all this, the humidity, I mean, of course, the temperature, humidity is derived from the temperature. So humidity essentially plays an important role. And I'll try to give you a very classic example of what happens in Delhi, that why do you get this fog, and then why in the surrounding area you do not get it. And we will try to talk a little bit about the secondary role of secondary inorganic aerosol formation as far as the fog in Delhi is concerned. So we just kind of going in the flow. We said that sources, natural and anthropogenic, how do they get affected? We said that the physical processes and then how the meteorology plays into the role. Then we said that what are the physical and chemical processes which are important and what within the meteorology is important. We are going to talk about it. Now, we said at the beginning that it has an implication on the overall biosphere as such, but then let's try to further bifurcate them. How do they affect the climate, for example? Well, I mean, through the formation of the aerosol and clouds, of course. Then you have the radiative forcing. I mean, some of them would react with the incoming solar radiation and then change it. And then precipitation patterns, that will not go into the detail on that. The ecosystem, this particular thing which I have added here, because I think some of the people here would appreciate more than me that why these water soluble inorganic species are important for the nutrient cycle, acidification and eutrophication. And then of course on the human health because of the respiratory and cardiovascular diseases and skin diseases. Now try to understand that when you inhale certain, you see a lot of paper and newspapers which says that if the PM 2.5 concentration increase this much, these many people are going to die. But that's basically purely based on the dose response relationship, right? Nobody really talks the physiological aspect of this, which is very complicated, but fortunately for what happens to us, more or less, whatever the reactions which they undergo in the atmosphere, similar reactions they go under your body before the biology tricks in. So I would be very happy to talk offline about it, that how the physiological interaction happens. Just to kind of put this something which is very simplified on the left hand side, I'm going other way around. Let's try to complicate it, how basically it happens. So you have ocean, obviously, right? Then you have the sea salt, and then you have the oxidation capacity, then you have volcanic eruption, and then we have a lot of anthropogenic activity. All these put it together, right? You have the aerosol formation, which we will talk about, the secondary inorganic aerosol formation. And then there are multiple processes, multi-phase processes within that. And then you have the liquid water content of the aerosol, then the pH of the aerosol, all that matters. I mean, just to give you a brief idea about like what we found in Delhi, when you have the concentration of PM 2.5 in Delhi, which is exceeding like 150 microgram per meter cube, what we do believe is that the amount of liquid water present in those atmosphere, in those aerosol exponentially increases, meaning that if your ambient concentration happens to be 600 microgram per meter cube, we believe 400 is anyway water in that. And where does it come from? Because of these water soluble inorganic species, right? So that is how they are really important. And then performing the ambient measurement is very difficult, right? Because when you try to sample the aerosol, you have to condition it, right? So once you condition it, it is an atmospheric measurement, but not the ambient measurement, right? So just try to get a difference between these two things. Now, when you talk about the climate, for example, let's try to go into the details of climate, ecosystem, and health. How does it differ? These are the most important components of the atmospheric particles, right? I mean, you leave out certain areas like Amazon or some areas where you have the clean, where you have more of an organic present in there. But generally in the polluted atmosphere, if you go, take out, there are many experts sitting here, ask them to show any one of data to you. So when you have the organic fraction there, which still dominates because of the primary emissions, but if you look into the secondary aspect of it, most of the time it is kind of dominated by these species, like sulfate, nitrate, ammonium, chloride. They are always present. These are the primarily dominant species. But if you go to Dr. Tannan's place, sometimes you something find potassium, I guess, right? So then that gives us a puzzle, and then we scratch our head and then do something and then still try to find out where does it come from. So let's try to take this one very interesting example of haze episode in India, and their concentration have positive correlation with the haze episodes, right? Always, particularly sulfate, nitrate, and ammonium, because ammonium, which comes in from the agricultural sources, I don't mean that to stop agricultural activities, but then you have this excess, it will neutralize the sulfate first. So you have ammonium sulfate, then you have nitrate, it will neutralize nitrate, and then you have ammonium nitrate, and then chloride. So what they have observed, this is a very interesting example, that this shows you the time series of the AMS or maybe the ACSM data, I don't recall that. And then you have this fraction of different species like organics, sulfate, nitrate, ammonium, chloride, and then black carbon concentration, and so on and so forth. What you see is that obviously as your time progresses, as the time is progressing, the concentration of these species is increasing. And once you see that the concentration of these species is increasing, try to look at the sulfate. It is at 10%, then 18%, and then 14, and then again 28%. So it basically goes up. So it clearly shows that when you have this H period which is coming up in here, you obviously have some sort of a higher percentage of inorganic species, and that's the reason they play an important role in finding that. Now let's try to come back to the actual topic which was given to me, that is about the role of the ionic species as far as the secondary inorganic aerosols formation are concerned. Now let's try to, I'm not going to go into the basic quantum physics or the physical chemistry or how it happens, but then when you have a phase change, that any vapor phase is becoming to the particle phase, like when you talk about this Gibbs free energy and then this entropy, and then you simply have some sort of a distribution, and then where does this energy come from? So that really goes up, and then phase change happens, and it goes on to the other side of your distribution curve. That's all what we have learned. I would be very happy about to talk it and then explain you that what do you really mean by the new particle formation. But that's for some other course maybe. But the ion can enhance nucleation, especially when neutral nucleation is weak. Meaning that if you have something which is in a steady state, that some sort of a molecules on the Gibbs free energy, the entropy is kind of not changing, and everybody is sitting on the equilibrium, this thing, all of a sudden occurrence of these species can kind of enhance the nucleation. You have these monomers and then very small particles coming in together and then kind of having this energy, and then it really goes on to the right hand side, and then immediately it nucleates. And then once you have a nucleation, of course the gases can go on to condense on it, and then it grows, and you know this theory about it. Now this, because the charge clusters, they generally tend to coagulate faster than the neutral clusters, right? And then once they kind of get faster nucleation then happen, and then they stabilize the critical cluster, right? And then once you have a critical cluster, it is stabilized, obviously, in terms of the molecules, obviously the condensation will happen. Now, for example, the sulfuric acid and water binary nucleation, if you just try to dissolve in that bond and then the energy which is available there, ions are more important at higher atmospheric temperature than the lower atmospheric, because you know that the crude way you can imagine is that the higher temperature obviously have higher reaction rates, and then the temperature, the reaction will be slower, so on and so forth. This is a very interesting paper which you must read. Now, for ammonia ternary nucleation, the presence of ions significantly enhances the rate, that is the nucleation rate, for higher temperatures, right? Simply because the dissociation or other sort of energy which you have available there would obviously create the nucleation. And this is the very nice graph if you look into the ion-induced nucleation of pure biogenic particles, meaning that you have the VOCs which are emitted from the biogenic activities like isoprene or monoterpene, for example. So if you look into the concentration of that, and then this is the nucleation rate, you can simply see that, these are the different points where you have this H2SO4 concentration. And then what you would see is that if you try to see this nucleation rate, majority of these points falling on these lines will kind of will fall into this reddish region, because this is where you can see that the presence of the sulfuric acid tends to enhance the nucleation rate and then the formation of the secondary organic aerosol. Now, into the ecosystem, for example, without going into the much detail, because that's not really my area to do that, but these species can inhibit the leaf killer decomposition rates. That's something which they call it as K, which is directly related with the carbon and nitrogen loss, right? And then as far as I understand it, if you have the carbon and nitrogen loss in that, obviously it is going to somehow affecting the photosynthesis. And if the photosynthesis is getting affected, plant will not really survive. The water-soluble inorganic ions in the PM2.5 particularly can influence the decomposition through soil acidification and salinization, which could also cause the sublethal deposition on soil kind of thing, right? The soil activity or one particular place, we have seen it at some point of time. Maybe if somebody here is the soil scientist can explain that. Over a shorter distance, they have observed that the pH of the soil really changes, right? And then I would probably believe that the deposition of these kind of a species could really change that. The long-term exposure, therefore, may have a very profound and negative impact on the ecosystem, which can alter some sort of a balance, and particularly the carbon flux of the ecosystem, and then nutrient cycle obviously will shape up because we just get the plants from there, everything grows in the soil, and then we don't know as far as the mass balance is concerned what is going in and what is coming out. Human health, well, not really critical, but then would be happy to talk about it afterward. What happens is the nitrate and sulfate ions, when they rapidly penetrate through the lung surfactant barriers, like surfactant is something like you use the wash powder, right? It's one of the best example of the surfactant effect, right? Now, the exposure to the nitrate and sulfate ions activates the cholesterol biosynthetic metabolism, like this lipid kind of a thing. So you have the aqueous solution where these ionic species are already dissolved, and then when you go to these lipids, obviously their interaction with that changes because the latent heat of what you call the solution when it interacts with the different lipid changes, and that's what one experiment which we will try to do it about it, that how do they basically change the metabolism in the body also. So the common inorganic species and their role in atmosphere, just to summarize this before I go on to the formation, the major component of fine particulate matter important for acid rain formation and climatic effect, that's sulfate. Then you have nitrate, also a major component and influences the ozone and other pollutant because the reaction which would happen on the aerosols, like you have currently talking about people talk about nitrile chloride and other things which are very toxic. Ammonium often coexists with the sulfate and nitrate and then affect the aerosol acidity and particle size. Scores of papers and then our own study shows that the presence of ammonium do really change the acidity of the aerosols, right? And that's acidity of the aerosol are major impact on the secondary inorganic formation, the way it takes up the water, and then when you inhale that aerosol, how does it basically change? Chloride, importantly, the major component of sea salt aerosol, influences cloud properties and precipitation pattern, but unfortunately not true anymore because you probably find more chloride in Delhi, which we do believe one of our paper in Nature Geosciences showed that it comes from the plastic burning, like because if you burn the plastic, this PVC type of plastic releases the HCl, and then you have excess ammonium. So ammonium is so high on that region that it neutralizes the sulfate. You still have some ammonium, it neutralizes the nitrate, it still has some ammonium, and then it kind of combines with the ammonium chloride, combines with chloride to give you the ammonium chloride particles, and they are really very bad, by the way. So water-soluble ionic species often lead to the formation of secondary aerosols. So finally, I'm coming on the topic, madam, which you have given me. So I think I still have around like
this
50.
was very important because we have not talked about water-soluble ionic species till now. So it was very relevant and we are thankful.
Sure. So I still have another 10 minutes, 15 minutes?
Yeah, you have your time.
Yeah,
and we have extended this session till 2 because Professor Gufranbek Saab has just landed.
Okay.
So we have extended this session till 2. We'll have lunch at 2 so that we can have.
So I'll not go for 1 hour, of course.
No. So we have
Yeah. So let's try to now talk about, like, once you understood the importance, their sources, how do they react, why they are important as far as the atmosphere is concerned. Let's try to understand how do they play an important role as far as the formation of the secondary inorganic aerosols are concerned. You might have heard a lot about the secondary organic aerosol formation, right? A lot of people might have talked, all the experts might have given you much details about it, but then although the processes may be same, that the fundamental physical and chemical processes may be same, but once they are formed, how do they basically go slightly different? Let's try to talk about this. Now, what you have is that you, if I look into, I'm sorry, go back here. If you look into here, you have the secondary aerosols, like, how do they form, like SO2, NOx, organics, oxidation, nucleation, then you have sulfate, nitrate, condensation groups. So, and then how do they basically affect that? They are CCN, and then they activate and then form the cloud droplet, and then you have soot, which also mixes that. These are primary particles, then wet and dry removal. This is just a cycle of the aerosols, what happens in the atmosphere. Now, the nucleation of gas phase species in the atmosphere lead to the formation of secondary aerosols. And one of the case which I will try to show you from Chennai itself, that we did observe that into the atmosphere. So let's try to simply take an example. At a power plant, you have a coal burning, sulfur gas, it's further oxidized to SO2, and then the further processes which happen in the presence of sunlight, and then eventually you have SO3, and then again OH radicals and everything, that oxidation process leads to the sulfuric acid, H2SO4 formation. Now, most of the time what happens, this H2SO4 gas would condense onto the pre-existing particles. Now, what we found in Chennai, a very interesting scenario during the lockdown, that when these pre-existing particles were removed, you really had a nucleation which is initiated by the sulfuric acid, and then we found a very high sulfate, right? So what it tells me is that when you don't have the when you don't have the pollution, how a different type of a pollution can have a different impact, right? I'll show you that case study. So this is one classic example that how does it basically the nucleation happens. The secondary aerosol contribute to nearly half of the total aerosol concentration globally, right? And if you include the secondary organic formation, that number is really very huge. So this is the misconception people they do have, and my personal belief based on this only one campaign which I did in Delhi, I believe that as far as the Delhi, if you say it is 100 microgram per meter cube, roughly, I may be wrong by factor of 5, I don't know, but then the major contribution in PM 2.5 Delhi comes from the secondary formation and not really the primary. Ionic species are more important for secondary formation.
Can I just talk?
Yeah, please.
But how you quantize that? How much is coming from the secondary formation?
Well, there are two ways of doing it. So what these people they try to do is that they have these measurements of this ACSM, AMS, and then this filter-based measurement. And then in the afternoon session, I'll try to talk about the source apportionment. Right? You apply the different techniques to try to understand that they just, so based on their mass to charge ratio in the mass spectrometer, and then based on the laboratory experiments, you try to say that like, okay, if I get this M by Z, meaning that this is attributed as coming from traffic. If I have this M by Z, it is coming from biomass burning. If this is then it's coming from cooking. So they call it as a source profiling, something like that they call it. And they put those numbers into some sort of a statistical model and then try to find out where the maximum it is coming from.
If you're essentially precursor gases, say sulfur dioxide.
Yeah, so that's what so one of the ways to do that is you have these VOC measurements, like which are primarily important. So major contribution come from the secondary organic aerosol formation. So what you do is that you systematically measure these VOCs. There are people like I think I believe the PRL Sahu et al. They have done some measurements, and then there is another group in ISR Mohali. They have done really a lot of work on this VOC measurement. So you understand use simple box models to calculate the yield of the secondary organic aerosol formation, right? And as you rightly said, that how do you know it? Well, of course, somebody has to go do those measurements and then try to sit across the table and then do those calculations, right? Why I can't do it? Because I'm far away from Delhi, right? So that's the reason it is not feasible for me to do that. I have to more often come to Delhi to do it. All right. The secondary aerosols could be organic or inorganic, right? And these ionic species are important for the secondary formation, as I have already mentioned. Now, understanding the secondary inorganic aerosols, their formation and then their implication in the atmosphere and then their processes. Now, try to understand that, of course, when you have this SOx, NOx, and then in presence of sunlight, when the gas to particle conversion mechanism happens through this oxidation process mainly, then you get the secondary inorganic aerosol, which are important for the cloud formation. Like the clouds cannot be formed without the presence of the aerosol. This, I believe you all might have convinced by now over the last 5 days that if the aerosols are not present there, you can't get the clouds, right? And if you don't get the clouds, you don't get the rain. No rain, no water, and then there is no life, right? So in a sense that we owe our existence to the aerosol, whether they are organic or inorganic doesn't matter. But let's try to appreciate this fact that they are present in the air, and then that's the reason we are existing. Now, these are the type of air pollutants that forms in the atmosphere from the interaction of gases emitted by human activities and natural resources, right? So both of them are coming in together there. Now, these are produced by the variety of the sources, including but not limited to the fossil fuel combustion, the power plants. That's the major kind of a source for the sulfate aerosols. Agricultural activity, livestock operations, fertilizer applications. That's basically contributes to the ammonium. Obviously, that's a large source of ammonium. And then the natural resources are kind of wildfires, volcanic eruptions, and dust storms. I think one could really look into this Duo et al. Paper 2020. They have very nicely explained this, and then the differentiation as far as how it really works. Now, most abundant secondary organic aerosol in the atmosphere is fine medium, at least when you look into the particulate matter which is less than 1 or PM2.5, it's obviously sulfate, nitrate, and ammonia. Invariably, everywhere you go, I think that Chan et al. Paper, I don't have it, but somebody might have shown it already, that across 30 locations, when we say that your major fraction is organic, then comes sulfate, then come nitrate, then come ammonium, and then come chloride, and Delhi has been an exception. This basically occurs mainly as ammonium nitrate, because I told you that ammonium, when it is as a cation, when it is present in excess, will try to neutralize. I think it try to neutralize the nitrate first. So I take that back. It first tries to neutralize the nitrate, so then it will form ammonium nitrate particles. Then comes to the sulfate, then it will form this ammonium sulfate particle, and then of course you have sodium as well, right? So through different mechanisms you can really get the sodium nitrate also. Now, these basically comes from the transformation of the precursor gases, the nitrogen dioxide, nitrogen oxides of nitrogen, sulfur oxides. And then also please try to understand that this chemistry works different during the daytime and during the nighttime. Right? So that's another challenge we have. Recently at a high altitude site in Munnar, we found probably a lot of ammonium nitrate, and we are not able to understand that where does it come from. Now, a detailed look into developing some box model and doing some chemistry and other thing which we found is that at the night time there is probably more of a nitrogen emissions because being a vegetated area, because they have this tea garden and everything. So we probably believe that some sort of a nitrate chemistry, some pathways which we would have to understand that how it plays an important role. So totally a different chemistry. So again, nighttime chemistry and daytime chemistry, that's also an additional complication which you'll always have to keep it in mind when you are doing it. The ammonia is the precursor for the atmospheric ammonia, right? And then it just basically combines for that. Combustion processes then give rise to your SOx and NOx, like sulfur dioxide mostly from power plant, NOx from the vehicular emissions. This ammonia is emitted majorly from the agricultural activities. Please don't get me wrong, to reduce these emissions, we would also need to have some sort of a control strategies to reduce the ammonia itself. That doesn't mean that I'm vouching to reduce the agricultural activity, right? We people at IIT are always scared because whenever we give this kind of a talk and then any reporter is sitting there, they go out and say that IIT faculty said that reduce the agriculture, right? So don't get me wrong. I'm just talking in terms of the emissions of the ammonia. Right. Yes.
Ammonia is neutralizing the acid formation of sulfuric acid and nitric acid. Then why should we degrade the emission of ammonia?
No, because eventually what happens is when it goes into the particle form, you need to have some sort of a cation to really neutralize it, right? I mean, you have a sulfuric acid, that's fine, but then eventually what happens? Let's say suppose in Delhi we find the hydrochloric acid. We have hydrochloric acid. Then to eventually get into the ammonium chloride particle, you need to have some sort of a neutralization, right? Because that, again, we'll need to look into this Gibbs free energy and then how the phase change happened, all those details in there, right? So only reducing the sulfuric acid could be, but then that's what the problem is. It's much more complex. What I'm trying to say. Yeah.
In this agricultural activities, if we can shift towards organic farming, organic fertilizer, then how badly this ammonia, because we are
exactly.
So one way is by shifting
that
organic fertilizers, we can reduce this.
Absolutely. I mean, that's one of the things that has a major benefit out of it, right? Now, the only problem is I don't know how much patience the people they do have as far as the organic farming is concerned, right? Because they said, "Sir, usko to bahut time lagta hai, pata nahi wo kahan se lana padega," right? So at some point, exactly. And that's the reason probably in the past we did not have this problem, because I don't know, somebody needs to tell me that it is true that the use of these fertilizers has exponentially gone up, right?
Yes.
Because what I understand that the amount of land which you have is the same or maybe even decreasing, I don't know. And then within this small thing, if you have to get more crop, and within this less time, there must be something which you are tweaking, right? Otherwise that's not possible.
Facing the same. What
Yeah.
you are saying, Punjab and Haryana soils have been getting the same thing.
कुछ तो किया होगा ना, मतलब आपके land हाँ, so I don't know, it sounds scary to me, right? That's okay as long as doctor.
Can I add something into it?
Yeah, please.
As I am from the agriculture background, and thanks to Dr. Shweta for giving me the opportunity to share my views over here. So, like you are talking about aerosols and its effect on agriculture and human health. I want to, like Dr. Pankaj also talks about the organic farming. There are certain other things which we need to discuss when we are talking about organic farming. No doubt, where there is a will, there is a way. We can also make, like we are having one state which is purely organic. The same thing we can replicate in the other states too. But the thing is, as per the agriculture census, we are having around 85% of the holdings are small and the minor ones, and their survival is at stake.
Yeah, yeah,
So
absolutely.
so when if there is a political will and there is a support from the government to those small and the minor farmers, then this could happen.
Right.
So ultimately, what I can understand out of your presentation also is that we need to make a balance. between
Always,
things.
always. I mean, that's what I
Thank
said.
you.
Like, I mean, I would prefer to have some ammonium chloride aerosols in the atmosphere rather than no food on my plate, right? Fine, perfectly fine, right? So there is no problem for me to either. And that way, when I'm foodie, I would say that different varieties is also
But,
required,
but
right?
I would like to add that slowly farmers are moving towards it.
The organic.
There is a positive way about it, and
Yeah.
farmers are moving towards organic.
Well, I mean, whatever could be the reason, right? In the end, it should land up in a situation where it is win-win for all of us. All right. So just to kind of, this again formation, you have this natural ammonia, and then from the agricultural activity, and then you have this anthropogenic emissions from various sources, and then they combine, and then you get these kind of a different aerosols anyway. Let's try to talk about how secondary inorganic aerosols are essentially formed to give you a very clear-cut framework of it. The nucleation, the homogeneous nucleation, where the vapors condense on to form the liquid particles, that the pure sulfuric acid, and then you have the very high sulfate particles. The heterogeneous nucleation, majority of the secondary particles are formed by the heterogeneous nucleation, where the newly created substances grow by condensing on them. So you simply look into it like you have the supersaturated vapor. The first thing which you really need is that obviously you need to have the supersaturated vapor, otherwise it does not happen. It just kind of disperses. And then you do have the one way of looking into it is the cluster formation, that they cluster, and this is where your the thermodynamics comes into the picture, which is very well established. And then you have this nucleation or the particle formation. And once that nucleation is formed, when you are on the right side of the distribution, by the condensation, it can really grow and then become a big particle. Then the other thing which you have the condensation onto the pre-existing particle. You have a very small particles, and then obviously you have the saturated vapor condensing on that, and then there is an increase in the size, and that really goes on to form the secondary inorganic aerosol. However, having said this, the conversion of gaseous species like these ones which are to the particles is the main pathway to form the secondary inorganic aerosols, such as the gas phase, aqueous phase, or the heterogeneous reaction. And then please also understand that these processes are multi-phase processes, right? You just can't really simply say that, Acha, ye ho gaya. No, it's not really that simple the way it happens. Then you have the chemical reactions. Si are formed through the complex chemical reactions involving oxidation of TSO2, as I have told you one example, and I will probably show that as well. These gases react with the water and then ammonia, because that's one of the major cations for sulfate, nitrate, and chloride to neutralize it. Then you have these particles that further react with other compounds in the atmosphere to form more complex aerosols, right? Then you have these different gases going through the particles, and then having some reactions on the surface, additionally creating some more gases or some sort of a toxic particles by surface reaction. So that also really goes into. And this is what a very nice paper would say, that how this aqueous chemistry, the concentration of these different species increases. You have the aqueous chemistry going down, and then if it is increasing, then the photochemistry really goes down. So meaning that if you don't have these species, that the photochemistry is important, but once you have these species, that the role of photochemistry really reduces. That's very interesting actually too. These are the adverse effect. Visibility reduction. The secondary inorganic aerosol can reduce visibility, create haze. I'll try to talk one very classic example of it. Ecosystem damage, as everybody agreed to it, like some sort of an acid rain formation. Respiratory problem, that's something which we are now looking into in much details, and really my favorite topic at this moment, because I just don't want to believe where somebody says that itna PM 2.5 badega to itne log mar jayenge. No, the dose response which was developed somewhere else for somebody else, I just don't want to really believe it. So unless I'm a researcher, so I work on work problem. Once I understand it, and then I go on to the second one. So I really want to know that what happens physiologically as far as this interaction is concerned. Then the cardiovascular diseases, that's one of the most linked increased risk of heart attack, stroke, and then other cardiovascular problem because they directly go into the lung. That's what they basically do. How are they measured? Well, I think it's good that one of the advantage being last year because we have had some sort of a hands-on on that. So I would kind of just sail through it smoothly. You have this online technique, which is aerosol sampling and analysis using the spectrometry, like aerosol mass spectrometer, aerosol chemical species and monitor, PTRMS, combined with the some sort of an aerosol module to that. So I apologize simply saying that it can measure the aerosol. It can't measure the aerosol. And then you have the chemical ionization mass spectrometry. Offline techniques. This place is known as a hub for aerosol offline techniques, right? I've been doing it for a very long time. So they almost they have everything here. They have the aerosol and cloud water sampling, passive samplers, ion chromatography, and there is something remote sensing and modeling. So I'm really an experimentalist. So I take the satellite and other measurement as a pinch of salt. Like sometimes for some validation and other thing is okay, but not to draw a big conclusion out of it. Will not go into the details of that. I would be very happy to talk about this if somebody has a question that any specific instrument, how it works. Maybe the previous respective speakers might have talked about it. So I don't want to. This is an ACSM, aerosol chemical. This is ACSM or AMS. It looks like it is an AMS. I don't know. But the difference is that the ACSM doesn't give you the size dependency of the chemical composition, whereas the AMS gives you the size dependency, whereas the ACSM doesn't give you the size dependency of the aerosol. You have these SIMs. This is very nice equipment, actually. I would really love to have it one. It works on the chemical. It's just that, like what it does, it selectively reacts with the ionized trace gases and aerosol in the atmosphere. And then it can basically be used to measure the concentration of gas phase precursor of SIAs, such as like SO2, nitrogen oxide, and ammonia. So all these instruments basically combined can give you a lot of additional information about their formation. Then comes the filter-based measurements. The filter-based measurements, of course, like you might have had the very interesting thing about it. So I'm not going to do like much detail of that. Passive samplers, that air sampling technique that allows for the collection of atmospheric pollutants over an extended period of time. You bring it and then do the bulk analysis over the time and space so that it gives an additional information. Ion chromatography, I don't think so. I need to go into the details of that. Offline techniques, X-ray fluorescence, any technique which is available, if you can try to apply your requirement wisely, some sort of an information you can always get as far as the aerosols are concerned. LIDAR, of course, I don't know how you can really differentiate between the secondary or the primary. I don't know, but then you could still use that. Passive remote sensing. DOAS is really a very interesting instrument that if you, I have had a very the scary experience about the DOAS when I was a postdoc. So that was my first assignment from the Max Planck side to go and then work in China. So we were in Beijing and then installing this DOAS instrument. I think it was very new at that time. And then वो बोलते हैं ना बचपन में मतलब वो एक बार कोई डर बैठ जाए तो आप वो कभी जाता ही नहीं. So इसलिए the whole reason I don't want to use the DOAS was because of this story. So we went in China, then Beijing, and then we were installing this instrument. And then I don't know if that instrument has become very advanced now. So it used to be like you fix the instrument, or you have to थोड़ा कुछ और distance जाके वहाँ पे उसका कुछ एक mirror fit करना होगा था, right? And then that mirror basically you have to align that you are seeing that mirror. So in that China and then with these people we went and then वो एक building में लगाए कुछ तो 200-300 मीटर जाके एक building में गए और उसको convince किया और वो हमने install किया वहाँ पे. And then when we installed that, we saw that अच्छा signal आ रहा है, हाँ signal आ रहा है, right? And then next day morning, everyone enthusiastically went there and said that चलो शुरू कर दें. जब उसको शुरू किया तो वो सिग्नल ही नहीं आ रहा है, तो पता नहीं चल रहा है कि मतलब क्या होगा. मतलब कल 4, 4.5, 5 घंटे काम किया उसको ये करने के लिए, तो सिग्नल क्यों नहीं आ रहा है. सो जब वहां जाके देखा तो पता चला कि वो आईना तो कहीं और ही था, जो रिफ्लेक्शन हम लोग देख रहे थे वो उनकी विंडो का रिफ्लेक्शन था. सो मैंने कहा इस टाइप के ऊपर काम नहीं करूंगा इसके बाद. मतलब वो विंडो भी समझ में नहीं आया और आईना भी समझ में नहीं आया, तो फिर कभी काम नहीं किया बॉस. But this is a very interesting instrument, by the way. If somebody has it, it can do the wonder as far as the atmospheric science is concerned. FTIR, every lab almost has this FTIR instrument, right? So you could really develop your own protocol. I think.
We also have it here.
Yeah, that's what I said. This is the hub for offline techniques, right? So now I'm worried that sometimes if they get online instrument also, they will overtake us. So then we'll have to do something that they don't get the online instruments, right? So FTIR, I think they have the FTIR.
Can you hear what
Sorry?
I think Nishant is sitting here from.
Yeah, well, whosoever. So donate mat kar dena, matlab paise leke dena. I mean, don't give it like that, right? You know, charge them. Anyhow, so this is the FTIR, and then FTIR is very old technique. I mean, people they have been using it for a very good amount of time, and then the protocols and the interpretation protocols are very well established. Because these techniques are used to estimate the concentration of SIS. That's very important, based on their spectral absorption property, right? So you can, I don't know if you can really quantify it out of that, but it can really give you a very preliminary information about how it works and then what their presence in the atmosphere are. All right, just to kind of pH and then the what liquid water content, you can see that, like, you know, if you look at this into the aerosol, like all these kind of reactions, what can happen around it, and then how it basically reduces the visibility, right? So now what I can tell you is that if you can go and read this Young et al. Paper, it's a very nicely described paper based on what we discussed here. What I can assure you is that if you would have read that paper before this talk, and if you read it now, you may probably understand a little bit better than what you looked into that. This is one of the case. I would just try to conclude with this thing. So this is this study from our own research at IIT Madras. So one of the students, Aishwarya, she was sampling in Chennai during the lockdown time, and then we have this very large power plant in Neyveli. 600 giga something like gigaton of SO2 per year. It's a huge power plant which was operating during the lockdown. Now what happened was we found a very strong new particle, or maybe the particle growth event on 1st of May 2020, but never seen something like this, right? And then when we tried to look into the chemistry of that, we found it like it was almost 50% sulfate during 8 o'clock in the morning till 6 o'clock in the evening, right? And then any new particle formation event, you go out of this room and then look into the new particle formation event composition, you would say that invariably it is 60% organic. You would never find that such a high sulfate is there as far as the secondary formation is concerned. Now, what happened in Chennai during that time, since it was a lockdown, that the pre-existing particles, they were very low. There were no pre-existing particle. Now, this very high sulfur emission kind of through this oxidation and other chemical processes landed up having an H2SO4. And that H2SO4 really then condensed to form the sulfate. Initially, so what we believe is that it was initiated by the organics, that the first one, but then this huge condensation was because of the sulfate. And then what we do see, and then the implication of it is that if you see the increase in the particle diameter, this is the increase in the particle diameter here. And then what we see is that the sulfate fraction. So as your particle diameter increase, just the particle when it becomes 150 nanometer, you almost had like 65% of sulfate. So which clearly said that, like, although it may not have been initiated by the sulfate, but then this condensation on those particles was very strong. Why? Simply because there were very low pre-existing particles. Otherwise, if you have a very large surface area, obviously it will be scattered, just like a tree, right? You may see that the tree is very small, but if you take out each individual leaf, it will cover like 3 football fields, right? So that's what exactly was happening there. And it had a very large implication on the cloud formation ability. So that gives us an understanding that, like, if you reduce one type of pollution, what impact it can have your climate and cloud formation. Well, this is, anyway, it better than me, so not really need to know that what you want to do with that. All right, so just to conclude this, my 45 minutes, secondary inorganic aerosols are significant and important as far as the adverse effect on the environment and humans are concerned. The formation of these aerosols is a very complex multi-phase process, and then the interaction with the precursor gases with the atmospheric component is important. So we just don't really need the SIA thing, but we also need to understand and know what do you basically talk about the precursor gases. That's extremely important. There are several strategies to reduce the secondary inorganic aerosols, including the air pollution regulations, cleaner technologies, and changes in agriculture and forest management practice, as the other Shweta ma'am was saying. But then we have to strike that balance. How do you strike that balance is very important, and then that's the reason you need to collaborate with the people. Don't work in silos. Then it is important to continue to study the formation and effect of these aerosols to better understand their impact and develop effective control strategies. All right, so I think with this, I would like to thank you for the attention.
Thank you so much, Professor Kunti. We can take one or two quick questions if we have.
Quick questions.
सर
Quick and small.
मेरा एक क्वेश्चन है कि जैसे हमारे पास मेजर आयंस
हमारे पास
मेजर आयंस में
Major answers.
जैसे हमारे पास एनायंस में सल्फेट नाइट्रेट और फ्लोराइड ऐसे ही हमारे पास अमोनिया कैल्शियम और मैग्नीशियम जो है। तो हमने बात की अमोनिया जो है उसका न्यूट्रलाइजिंग क्या क्या है, कैसे